Assalamu alaikum. This is lecture number 8 in the course of statistics methods. For this part is the probability. It is the third lecture for probability. First lecture for probability, calculate how to get the value of the probability and axioms for probability and solve many problems about probability. Second lecture for probability about conditional probability. And after conditional probability, we get what is the random variable and explain the random variable discrete, because random variable consists of discrete random variable and continuous random variable. Now, this lecture we will explain continuous random variable. The difference between discrete random variable and continuous random variable. Discrete random variable, the variable is countable, i.e. can be counted like 1, 2, 3 and so on. But continuous random variable, the variable is continuous, meaning is interval x greater than and less than is called continuous. So we want here to calculate what is the probability of x greater than a less than b. And the discrete, calculate x equal value. So probability of x greater than a less than b is equal to the area under the curve. Area under the graph between x equal a and x equal b. The area between x equal a and x equal b is called the integration. So integration from a to b f of x dx is the probability. So probability of x is random variable, greater than a less than b equal integration from a to b f of x dx. We see that the curve between x and f of x and is curve that's there. Want at x equal a, x equal b, between that is the area. Want the probability between x a greater than a less than b. So the function f of x is called the distribution function. Distribution or the continuous probability function. There is another name for this distribution called density function. So this function is the probability of x greater than less than. We have the condition for that. First, f of x is the probability function. F of x must be greater than equal 0. Number 2, integration for all domain. What means all domain? From negative infinity to plus infinity, which define f of x dx must be equal 1. Third condition, probability of x greater than a less than b equal integration from a to b f of x dx. See the difference between here and discrete. Discrete is summation. Continuous is integration. For discrete, summation f of x dx a summation of probability p of x must be equal 1. Here is the integration. We have in continuous random variable. Also what's the expectation? The expectation, expectation value is equal mu is equal summation x f of x. Here for continuous is the integration for all domain from x is a of x f of x dx. Explication of x square y to calculate the variance. Explication x power 2 equals summation for domain x square f of x. What is the variant? The variant is ex power 2 minus ex total power 2. Expectation of x square minus mean square. That is the definition. You have to know these definitions very good to calculate. First example for continuous random variable. That x meaning random variable is be a continuous random variable with distribution density function. Distribution density function f of x, where f of x equal kx. What's k? K is a constant for x from 0 to 4 and equals 0 otherwise. First thing, we want to calculate this constant k. So how to calculate? From the properties which we said in the last slide. Number 2, we find probability x greater than 1 less than 2 and probability of x less than 2. Third, we find the mean mu and standard deviation sigma x. To solve this, to get kx, we have integration for all domain f of x equal 1. What's all domain? All domain is from 0 to 4. So we can get k. To get probability x greater than 1 less than 2 is the integration from 1 to 2, the value of k which you get times x. Number 3, to get the probability x less than 2, this meaning probability from 0 to 2. After, to find mu is the integration x f of x. To find sigma x, first find variance equal ex power 2 to integration x power 2 f of x minus ex total power 2. So to solve this problem, first, since f of x is density function, equal integration from infinity to infinity f of x dx equal 1 to be density function. Integration for all domain of the function must be equal 1. Then the function is defined from 0 to 4. So integration from 0 to 4 k x dx equal k x square to be the integration kx square over 2 from 0 to 4. The value we get k is equal 1 over 8 equal 0.125. Then f of x function defined by is k with 1 over 8x. Is the first thing. Second thing, we want to get the probability x greater than 1 less than 2. So integration from 1 to 2 f of x. What's f of x? 1 over 8x. So 1 over 8x dx equal 1 over 8 x squared over 2 from 1 to 2. Substitute, we get the probability. Notice that probability here greater than 0, less than 1, it's correct. What's the probability of x less than equal to? The random variable defined from 0 to 4. So when integration from 0 to 2, f of x 1 over x dx. Substitute, we get the result 0.25. So first required, second required, okay. What's the third required? Expectation. Expectation is mu. The definition of mu e of x integration x f of x for all domain from 0 to 4 x f of x dx. Substitute, we get the want the standard deviation. To calculate standard deviation, first calculate the variance. What's the definition of variant? The definition of variant equal ex power 2 minus ex total power 2. So we calculate first ex power 2. Ex power 2 is the integration x power 2 f of x. We make the integration, we get this value. So substitute to get variant. Variant is equal ex power 2 is equal 8 minus ex total power 2 x 2.668 power 2, and with the difference we get the variant. What is the standard deviation? The standard deviation is the square root of the variant. With the square root we get the standard deviation. We defined before the probability density function small f of x. Density function f of x. Density function probability from x equal a to b integration from a to b f of x dx. But cumulative making addition, cumulative addition, total. Let x be a random variable, discrete or continuous. Discrete random variable or continuous random variable. The cumulative distribution function with the symbol capital F of x dx. Capital F of x is defined by capital F of x equal probability of all random variable less than certain x. So probability of x less than x. For discrete, what means for this? For discrete is summation for all x less than special x of f of x. For continuous is the integration from negative infinity to some value x, small f of x. So capital F of x in discrete, summation. For continuous, integration. Summation all values less than x. Integration from negative infinity to x. All domain till x. This is called cumulative distribution. We see that before properties of probability density function or density function. Now, what's the properties of cumulative probability function, capital F of x? First, capital F of x greater than 0, less than 1, the same like density function. Number 2, probability of xi less than equal probability of xi plus 1. This means increasing function. Cumulative. It's cumulative. Second, it have to be more than the first. Number 3, for all domain x from negative infinity to infinity. So if capital F of negative infinity must be equal to 0. Capital F of infinity must be equal 1. Why if of infinity so on equal 1? Because we add all the f of x, summation of the add equal to 1. And if x, to get probability of x greater than a less than b, we have to be f of a, I mean cumulative at b minus f of a. Cumulative at a. So probability of x greater than a less than b is equal f of b minus f of a. Take care from capital F and small f. We get an example about cumulative function. If x is a continuous random variable where x defined from 0 to 3, x greater than 0, less than 3, if the distribution function for cumulative capital F of x equal k x about 3, find the probability density function. We want small f of x. We know that capital F of x equal integration small f of x. So small f of x equal derivative capital F of x. Meaning density function equal differentiation of cumulative function. So we have cumulative function capital F of x kx power 3 to get probability density function. So small f of x equal g by gx kx power 3, d by dx capital F of x. So f of x equals 3 kx power 2. So we want small f as small f. What is here? K. What's k? K is constant. We have to get k. To get k, we have the condition. Capital F of 0, f of negative f of equal 0. Capital F of large f of infinity equal 1. F of 0, put x equals 0 to 0. F of infinity, what's infinity here? It's 3, defined till 3. So f of 3, substitute by x equals 3 in 3x power 2, we get k equal 1 over 27. So small f of x is the distribution function, or is the density function, equal x power 2 over 9. First example for continuous random variable. That x meaning random variable, is be a continuous random variable with distribution density function. Distribution density function f of x, where f of x equal kx. What's k? K is a constant for x from 0 to 4 and equals 0 otherwise. First thing, we want to calculate this constant k. So how to calculate? From the properties which we said in the last slide. Number 2, we find probability x greater than 1 less than 2 and probability of x less than 2. Third, we find the mean mu and standard deviation sigma x. To solve this, to get kx, we have integration for all domain f of x equal 1. What's all domain? All domain is from 0 to 4. So we can get k. To get probability x greater than 1 less than 2 is the integration from 1 to 2, the value of k which you get, times x. Number 3, to get the probability x less than 2, this meaning probability from 0 to 2. After, to find mu is the integration x f of x. So to solve this problem, first, since f of x is density function, equal integration from infinity to infinity f of x dx equal 1 to be density function. Integration for all domain of the function must be equal 1. Then the function is defined from 0 to 4. So integration from 0 to 4 k x dx equal k x squared, to be the integration kx squared over 2 from 0 to 4. The value we get k is equal 1 over 8, equal 0.125. Then f of x function defined by is the k. Second thing, we want the distribution function. The distribution function means cumulative distribution function, capital F of x. From the definition, capital F of x equal in integration from negative infinity to x, f of x dx. So step by step. Number 1, if x greater than 0 less than 1, so integration from negative infinity to 0 plus from 0 to x. We get capital F of x from negative infinity to 0 is 0. From 0 to x is x. So the integration from 0 to x is x, equal x squared over 2. That's step number 1. After that, from 1 to 2, x from 1 to 2. So integration from negative infinity to 0 plus 0 to 1 plus 1 to x. From negative infinity to 0 is 0. From negative 0 to 1, f of x equal x squared over 2, substitute by x equal 1 equal half. And from 1 to x, what f of x? K is equal 2. So it's equal 2 minus x dx. And integration, so f capital F is equal to x minus x squared over 2 minus 1. So f of x from 0 to 1 equal x squared over 2. From 1 to 2 equal 2x minus x power 2 minus 1. Number 3, if x is greater than 2, so make the integration. Negative infinity to 0 plus 0 to 1 plus from 1 to 2 plus from 2 to x. From infinity to 0 is equal 0. From 0 to 1 equal half, which we get x squared over 2. From 1 over to 2 equal 2x minus x squared minus 1. Greater than 2, from 2 to infinity, we have to substitute x by 2. So our distribution function here, x less than 0, capital F of x equals 0. X from 0 to 1, capital F of x equal x squared over 2. From 1 to 2, capital F of x equal 2x minus x squared over 2 minus 1. Greater than 2, we substitute x by 2 here. Here 2 times 2 is 4. 4 minus 4 over 2, 2. 2 minus 1, so 4 minus 8 is equal what? 1. That is the distribution for capital F of x. What is the probability of x greater than 0.3 less than 1.5? F of p is a and b equal f 1.5 minus f 0.3. So f of 1.5, well, where is f 1.5? Where is here? Substitute x by 1.5. So 2 times 1.5 minus 1.5 square over 2 minus 1 minus f 0.3. What is 0.3 is here? From 0 to 1. Substitute x 0.3. So 0.3 power 2 over 2. And you get the result 0.83. Remind again the variance and the standard deviation. The variance defined by expectation of x expectation x power 2 minus expectation of x all power 2, meaning we get first expectation of x power 2 by continuous function is integration negative infinity to infinity x power 2 f of x minus f of x total power 2 is mean minus mean power 2. How to get the mean? The mean is integration f of x is integration x f of x dx. We calculate it, get the variance. What is the standard deviation? The standard deviation is equal to the square root of the variance. Okay. To make an exercise about the random variable. First one, let x be a random variable having probability density function small f of x equal to x 0, x from 0 to 1, 0 otherwise. Find the expectation. Easy. The expectation is equal integration x f of x. So x times 2x, and from integration from 0 to 1, we get the expectation. What's the variance? First, calculate expectation x squared. So integration from 0 to 1 x squared times 2x dx. And with the result minus, we get the mu square minus expectation square. This is the first example. I think is only direct about formula. Another example, let x be a continuous random variable that has the following probability. The very famous example and the very problem. Very important. F of x equal c e to minus 3x x greater than 0 equal 0 otherwise. What is required? First required what is c? C is a constant. To get the constant, by definition, integration from 0 to infinity, c e to minus 3x equal 1. We get c. Number 2, what's the probability x greater than 1 less than 2 is the integration from 1 to 2 f of x. Now, after that, probability of x greater than 3 is the integration from 3 to infinity f of x. X less than 1 is the integration from 0 to 1 f of x. What's the expectation value? Expectation is the integration x f of x from 0 to infinity. Variant. First calculate expectation x power x power 2 integration from 0 to infinity x square f of x minus mu square. Another example, let x be a continuous random variable has the following probability function. F of x equal k x power 2 plus 2x plus 2 from 0 to 4. 0 otherwise. Find first k to get k. So integration from 0 to 4 f of x kx squared plus 2x plus 2 dx equal 1. What is the required k? We can get k. The distribution function lies what is the distribution function? We from infinity to 0 equals 0, and from 0 to 4 kx. No, not from 0 to 4, from 0 to x. We get that. Of that from x from 0 to x, yeah. What's f of 2? F of 2, if I get, after I get f of x, substitute by x equal to, for what x equal greater than 1, less than 3, direct integration from 1 to 3, f of x directly.